How do we learn, and why do some people grasp things more easily than others? These questions are fundamental in brain research, a field that helps us understand human physiology and what shapes us as individuals. This is an exciting time to study the brain, with our knowledge expanding rapidly and challenging previous assumptions. For instance, it was once believed that the brain couldn't change after childhood. Now, research shows that the brain is capable of change throughout our lives. Another misconception was that the brain uses only certain parts at a time and remains inactive at rest. However, even when we're not consciously engaged in a task, our brain remains highly active. Advances in technology such as MRI have revealed that each time we learn something new, our brain physically changes, a phenomenon known as neuroplasticity. As recently as 25 years ago, scientists thought brain changes after puberty were mostly negative, like cell loss with age or damage from strokes. Now we know that our behaviors continually reshape our brains, regardless of age. This adaptability supports learning and recovery, even in adulthood. The brain adapts to learning in three primary ways: chemically, structurally, and functionally. Chemically, neurons communicate through signals, and learning increases the concentration of these chemicals, supporting short-term memory. Structurally, learning can physically alter connections between neurons, supporting long-term memory and skill retention. For example, when learning a skill like juggling, improvements initially seem temporary because structural changes haven't yet solidified. Over time, repeated practice can cause areas of the brain to grow, as seen in people who read Braille or memorize maps. Lastly, functionally, using a brain region makes it easier to activate, enhancing learning efficiency through shifting network patterns. Together, these changes support learning. If the brain is so adaptable, why is learning sometimes difficult? And why don't all brain injuries fully heal? Research has shown that behavior is the main driver of neuroplasticity. However, relearning or mastering new skills often requires extensive, difficult practice. Approaches like brain stimulation, exercise, and robotics are being developed to help prepare the brain for learning. However, neuroplasticity varies significantly among individuals, which has shifted research toward personalized medicine. Just as cancer treatments are now customized, there's potential for tailoring brain therapies to individual characteristics, which could improve recovery and learning outcomes. Studies reveal that there is no universal method for learning. Strategies that work well for one person may not work for another. This insight extends beyond recovery to all areas of life, from traditional education to skill building in adulthood. Each behavior we engage in reshapes our brain, which explains why some learners excel in traditional schools while others thrive in alternative environments. When you reflect on these findings, consider how your brain is constantly being shaped by what you do and experience. This change can be positive or negative. Practice healthy brain habits, find learning strategies that work best for you, and break patterns that hold you back. Your brain is always adapting. Go out and build the brain you want.